All right, so guys, the next section here is 4.3. It's more discrete probability distributions. All right, so guys, we have something called the geometric distribution. And so the way we're going to know whether or not we have a geometric distribution is, number one, a trial is going to be repeated until a success occurs. Repeated trials are independent of each other. The probability of success P is the same for each trial. The random variable X represents the number of trials in which the first success occurs. And the probability that the first success will occur on trial X is, and it gives me a little formula right here, okay? All right, so let's take a look at the first problem, and it says, basketball player Tony Parker makes a free throw shot about 80% of the time. Find the probability that Tony makes his first free throw shot on his third or fourth attempt. Okay, so guys, when I do this problem, there's a couple things I need to know. I need to know the probability that he's going to make that free throw. What's the probability he's going to make the free throw? 80%. How would I write that as a decimal? 0.8. Okay, good. The next thing we need to figure out is, because if you notice right here, there's a Q in my formula. What's the probability that he's not going to make the free throw? 0.20, right? Okay. So guys, I want you to look at this part right here. It says we're going to figure out on his third or his fourth attempt. We're going to figure out on his third or fourth attempt. So guys, if I wanted to figure out what's the probability that he's going to get that free throw in his third attempt, I'm just going to use this formula right here, okay? P of 3 is going to be equal to the number P. What did we say our number P was? 0.80, right? 0.80 times Q. We said our number Q was 0.20. To what power here? X minus 1. What's our X number in this case? So guys, I know I could write 3 minus 1 is 2, but just for the sake of making this easy, I want to show you how I'm going to do it. I'm going to write it as 3 minus 1. Before I do anything here on my calculator, let's figure out what's the probability that Tony's going to get his free throw on his fourth attempt. So I'm going to do the same thing. I'm going to put 0.80 times 0.20. Look at my power. It's going to be X minus 1. So I'm going to write 4 minus 1, right? And then I'm going to figure out what my answer is for each of those. So guys, the first thing I'm going to do, I'm going to grab my calculator again. So here it is. Let me turn it on. Let me clear my screen. Okay, so the first part here, guys, I'm going to take parentheses. I'm going to type in 0.80. I'm going to close off my parentheses. And then we're going to multiply. I'm going to put parentheses again. What number? 0.20. Okay. I'm going to close them off. And then, guys, I'm going to use my exponent button. The way I'm going to do this on my exponent, I'm still going to go ahead. I know I could write the number 2, but I'm just going to go 3 minus 1 and close them off. Got to do that number there. Okay, and then hit enter. Oh, man, what did I do? Go to. Oh, I put a negative instead of a minus. There we go. Okay, so 0.032. Okay, so let's go to 0.032. That's the probability that he's going to make his free throw shot on the third attempt. Now, let's do the same thing for the fourth attempt. So, guys, for the fourth attempt, couldn't I just go second entry and change that number 3 to a what? There you go. And then hit enter. And I'm coming up with 0.0064. So 0.0064. Guys, when it says we're going to find the probability that he's going to make this either on his third or his fourth attempt, what we're going to do, we're going to add those numbers together. So probability of 3 plus the probability of 4. If you add those numbers together, guys, are you coming up with something like 0.0384? Okay, there you go. Boom. Now, I want to come back. I want to look at the same problem that we were doing. And look what part 2 says. Find the probability that he's going to make his free throw shot on which one? The first or the second? So we're going to figure out what's the probability he gets it right on the first, and what's the probability he's going to get it on the second. So guys, let me ask you a question. I mean, I could write out my entire formula again, or I could come back to my calculator, and when I go second entry, if I'm going to go to the first attempt, I'm going to change that 4 to a what number? A 1. Okay, and I'll hit enter. And so the number that I'm coming up with here is 0.8. 0.8. And then I'll come back to my calculator again, and I'll go second entry. Oops. Second entry. And I'm going to change that first one now to a what? To a 2. And I'm coming up with 0.16. And so now, if we want to figure out what's the probability he gets it either on the first or the second, we're going to take those numbers, we're going to add them together. Are you coming up with something like 0.96? There we go. Okay. That's just the formula. So the formula is always going to be that formula x minus 1 up there at the top. Guys, this summer, like when I think I told you guys I sat in on that stats class, and somebody asked, how do you come up with these formulas? Guys, there is a lot of calculus that goes into those formulas, and that's actually how they're derived, is using a whole lot of calculus. What we need to really figure out is, do we know how to apply the formula? Can we figure out what to do? But
so you enter 4 minus 1 and then?
Yeah, because look at my formula, right? My formula here has, what is my exponent? X minus 1, right? So whatever number that is, that's going to be my 3 minus 1, or 2 minus 1, or 1 minus 1, or 2 minus 1, or 4 minus 1, right? That's just how my formula is written out. Okay, so guys, the whole point of geometric distribution is you're going to keep trying until you get it, right? So like if you notice here in this problem, Tony Parker's trying to make his free throw. We're looking for when's the probability that he's actually going to get it, either on his first attempt, or in his second attempt, or his third attempt, or his fourth attempt, right? All right, and then let me scroll down a little bit more. Huh? Yeah, I know. He's not around anymore, right? All right, so guys, there's another distribution here called the Poisson Distribution. Let me see if I can get a better color. Oh, I don't know. Let's go with green. Okay. So a Poisson distribution, guys, is the discrete probability distribution with a random variable x. It satisfies. Okay, it says the experiment consists counting the number of times x an event occurs, bless you, in a given interval. The interval can be of time, area, or volume, okay? And bless you, the probability of an event occurring is the same for each interval. The number of occurrences in one interval is independent of the number of occurrences in other intervals. And guys, we have a formula right here, okay? And it says the probability of exactly x occurrences in an interval is the probability of x. So guys, remember what the mu stands for? The mu is my average, right? So mu to the power x, and then e to the power negative mu, all over, remember, x factorial. Remember 5 factorial means 5 times 4 times 3 times 2 times 1, right? Okay, so do me a favor, if you scroll down to the next page, right here. Okay, so here it says the mean number of accidents per month at a certain intersection is 3. What's the probability that in any given month 4 accidents will occur at this intersection? Okay, so guys, I'm going to use my calculator again. So instead of me having to use that formula with the mu to the power x and e to the power negative mu all divided by x factorial, my calculator has something called the Poisson probability distribution, okay? So first thing we're going to do, number 1, what is our mean? Does it tell me what the mean number of accidents is here? It tells me right here, the mean number of accidents is 3. You got to read, my friends, okay? All right. Now, what is the probability that in any given month, how many accidents are going to occur? All you got to do is read, my friends, okay? All right, so guys, I'm going to come back to my calculator, right? Let me see if I can grab it down here. Okay, let's clear this sucker out. All right, so I'm going to go again, guys. Second vars. and I'm going to scroll down, and I'm going to look for the one that says Poisson PDF right there. Okay, so I'm going to click on that button. Okay, so there it is, Poisson PDF. I want you to look at the formula, guys. Right here, we're going to put two numbers. Okay, we're going to put two numbers. The first number is going to be mu, very good, and the second number is going to be our x. Mu is always going to be the average. So mu, think of it kind of like a U with a little, like a little slant. There you go, right? 3 comma what? 4. Close off your parentheses, hit enter, and there's my answer. So guys, again, let's go to 4 decimal places. That's what we've been doing. So would I say 0.1680 or 0.1681? 80, okay, so 0.1680, there's my answer. Okay. All right, now I want you to look at the next part here, okay? The next part says, what's the probability that what? What does less than 4 mean? 3? Is that the only one? 2, 1, or how many accidents? Or 0, okay. So guys, less than 4 means we're going to look at the probability of 0, probability of 1 accident, probability of 2 accidents, plus a probability of 3 accidents, okay? We could do the Poisson Distribution PDF. We could do it 4 times. We could do it for 0, we could do it for 1, we could do it for 2, 3, or 4. But remember, do y'all remember what the C stands for? I wrote it up here on the board, so if you... Yes, cumulative, right? That's we wrote that up there earlier. So that C, guys, stands for cumulative, okay? So what we're going to do, we're going to now use our calculator, and I'm going to go second vars. I'm going to scroll down until I hit Poisson CDF, because I want the cumulative one, okay? And I'm going to do the same thing, guys. I'm going to put our mu. What did we say our average was again? 3. Okay. And then if we want less than 4, the last number we're looking at is how many accidents? Is 3. Okay. Close that off. Enter. And we're coming up with 0.6472. 0.6472, right? All right, so let's take a look. If your calculator, guys, is a little bit newer, then you're going to turn it on. Let's clear that out. Second vars. Okay, we're going to go like this. Which one are we looking for again, guys? Poisson CDF, right? And hit enter. Okay, that's my mu. That's my average. Okay, what number was our average here? 3. Okay, my x value, 3. Enter, enter, enter. Same thing? Same thing. Okay. And there you go, right? So it'll work out the same way, guys. You're just basically entering the same numbers, right? Okie-dokie. So again, let me switch back, okay? So guys, look at part 5. Part 5 says, what's the probability that 4 or more accidents is going to occur? Let me ask you a question. What does 4 or more mean? 4, 5, 6. Would we stop? Or would we keep going forever and ever and ever? So but hold on. We could stop there, but would that be the right thing to do? Right, but look at the question. The question is talking about. So, guys, I want you to think about the original. I want you to think about the original question, right? The original question is talking about what? The number of what, guys? The number of accidents, what? Per month. Okay, let me ask you a question. Could there be 100 accidents in 1 month? Could there be 500 accidents in 1 month? Okay, so let me ask you a question. Should I stop at 6? No. I would have to keep going for how long? Forever, right? And so we can't do that, right? Because when are we going to stop? We don't know. But if the directions are saying we're looking for 4 or more accidents, right? We're looking for 4 or more accidents. If we found the probability that, if we found the probability that less than 4 occurred, could then we find the probability that 4 or more would? 1 minus, right? So guys, couldn't we do 1 minus the 0.6472, right? Because we already know what the probability of less than 4, so now we want to find the probability of 4 or more, we're just going to take 1 minus that answer. What number do you come up with? Point something? 3528? There you go. Okay. All right. So again, guys, the main thing here is not only how do I do this on my calculator, but understanding the idea of what does less than 4, what does 4 or more mean, right? And then being able to understand when would I use my cumulative distribution, whether it's binomial cumulative distribution like binomial CDF or Poisson CDF, when would I use it depending on what is the question asking me, right? If it's asking for an individual probability, then I'm going to use my binomial or Poisson PDF, right? Because it's asking for a specific value. But if it's asking me for so many or more, if I know how many are less than that, then I can do 1 minus that answer, right? And if it's asking me how do I find the probability that it's less than that number, less than or equal to that number, then I can use my CDF type of formula, right? But again, a big part of it is just figuring out what is it asking me to do, okay? So guys, here's another problem. It does give me a table. So let's see if we can figure this out. Just looking at our table here. So I'm going to come back, I'm going to grab my pen. Let's go here. Okay. So do we know what our average is in this case? Yes. So guys, my mu is 3.6. Okay. And now we're going to look for what's the probability that how many rabbits? 7. Okay. So look, guys, here's my 3.6, right? And then we're going to go to what number? What number are we going to use? 0.045? 0.0425, there you go, sorry. 0.0425, right? All right. Guys, let's take a look at the next part here. Look what it says here. A mail order company receives an average of 5 orders per how much? 500. Okay. Now, I want you to look at the next part of the question. The next part of the question says, if it sends out 100 advertisements. Guys, look what we had here. If we had 500 solicitations, which is the same thing as advertisements, then our average was what number? 5. How many times or how many advertisements did we send this time? 100. What do you think my average here would be? 1, right? Because look, if it's 5 for 500, wouldn't it be 1 for 100? Okay. Find the probability of what? At least 2 orders. Use the, which one? The Poisson. Okay, so guys, remember what at least 2 orders means. It means that we're going to get 2 orders, or we're going to get what? Hold on. What does at least 2 orders means? 2 and what else? Guess again, guys. At least 2 or 3 or what? Or so on and so forth, right? Okay. So we know this is what at least means, right? At least means that is your, think about it this way, guys. At least is telling you your bottom number, right? The lowest you're going to go is 2. So if it didn't give me a higher number, then my highest is going to keep going until whenever we stop, right? So if we already know that our mu is going to be 1, right, and we're looking for the probability of 2 or greater, couldn't we use our Poisson CDF, the cumulative, right, with our mean and our x, and Fred is saying, let's use our mean to be 1 and our x also to be 1, right? So again, guys, I'll get my calculator here, and I'm going to go binomial or Poisson CDF, and they're both going to be what number? 1 and 1. And I come up with that, right? But that's telling me either none or one. And if I want to know 3 or more, then I have to do 1 minus what? Yeah, 1 minus my answer. And I'm coming up with 0.264, 2642. 0.2642. All right. So guys, I just have 3 more problems on the next page, and then we'll be done. Oops. So let me scroll down un poquito. Okay. So I picked these problems here, guys, because you have problems very similar to these in your homework. So let's see if we can figure out which ones this is going to be. So number 1, it says, find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. Then determine whether the events are unusual. If convenient, use a table or technology. So guys, when you're doing these problems in your homework, you might be able to use a table if it's there, okay? I'm going to use the calculator here because I don't have a table in my notes. So number 1, it says the probability that you're going to make a sale on any given telephone call is 0.19. Find the probability that you make your first sale on the 5th call, or you make it on the 1st, 2nd, or 3rd call, and that you do not make a sale on the first 3 calls. So now what I got to figure out is which of these distributions is this gonna be like a binomial distribution or a geometric or the Poisson, okay? So guys, if you look back at your notes, and I'm just gonna look at my notes from what we were doing earlier today. I'm gonna switch back over here so we can see this. Okay, look what a geometric says. A trial is repeated until what? Until a success occurs, right? So when I switch to this back over here, we're trying to figure out what's the probability that we make our which sale? Our first sale on the 5th call. This is telling me this is going to be geometric. I'm going to keep calling until I am able to sell something, right? Whatever it is that they're selling. So this is going to be a geometric because we're going to keep doing this until we're successful. Okay, so this is going to be geometric. The probability that we're going to make our sale is what number? 0.19, right? Guys, let me ask you a question. What's the probability that we do not make a sale? If it's 0.19, what would be the 0.81, right? Okay. Guys, I want you all to do me a favor. Look back at your notes where we're looking at geometric and look at the formula that we were using. Do you see the formula right here with the P of x equals P times Q to the power x minus 1? That's the formula we're going to use, okay? So, guys, for part A, okay, my formula is P of x equals P to the power Q x minus 1, okay? In this case, we're going to make our first sale on which call? On the 5th. So that tells me I'm going to find P of 5. So the first thing I'm going to do, I'm going to type in my number P, which is 0.19. I'm going to multiply it by 0.81 raised to the power 5 minus 1. So the first thing I'm going to do, guys, I'm going to grab my calculator right here. Let me clear that out. Okay, so we said 0.19. Close it off, times 0.81 to the exponent of, to the exponent of, what were we saying, 5 minus 1? 5 minus 1. Close that off, enter. Okay, so guys, the probability that we're going to make our sale on the first sale, or the 5th call, I'm sorry, is, if I go to 4 decimal places, 0.0818. 0.0818. There we go. Okay, now let's look at part B. Part B says we're going to make our sale on the 1st, the 2nd, or the 3rd call. So guys, what I'm going to do, I'm going to find the probability I make it on my 1st. And then Yeah, and we're gonna accumulate all the way until we get to 3, okay? So guys, I'm gonna come back to my calculator, right? Guys, can I go second entry? And then I'm just gonna change that first 5 to a what? To a 1, good. And we'll hit enter. So the first number I have is a 0.19. Plus, I'm gonna come back again. I'm gonna go second entry. And the second thing I'm gonna do is I'm gonna change that first 1 to a what now? To a 2. Okay. Hit enter. And I'm coming up with 0.1539. And then we're going to do that one last time. Second entry. And then all we're going to do is change that first 2 to a what? To a 3. Are we doing okay so far? Okay. So point, that'll be one away, let's see. 1247. Thank you so much. 1247, right? And then what are we going to do with those numbers now, guys? Add them all up, right? Okay, so let's go ahead and do that. So let's see. 0.19 plus 0.1539 plus 0.1247. 0.4686. Good. Okay, so let me see if I can move this a little bit to my side. All right. So now that we got that part, let's come back over here and let's look at part C. Okay. Part C says, let me get my eraser here. That's what I was trying to erase right here. Okay, so part C says we what? We do not make our sale in the first 3 calls. Well, guys, we already figured out what our probability was if we did make a sale in the first 3 calls. How would I find the probability that I'm not going to? 1 minus, there you go. Man, I could have stayed home tonight. 1.4686, very good. Guys, that's the part that I'm looking for. So I'm glad Myra told me 1 minus, because that tells me that you're getting the idea of what it is that we're trying to find, right? Okay, so guys, if we go 1 minus 0.4686, are you coming up with 0.5314? There you go. Good. Very good. Look, let's put it this way. What's the hardest thing you had to do? Come to class, right? But think about it this way. Let me ask you this. Was part B, and let me ask you a question. Was it hard or was it time consuming? It's time consuming, right? But what you're doing is you're really second entry, right? And doesn't that save a whole lot of time? Right? So remember, Fred, I'm not telling you here's 2 sticks, rub them together, make a fire, right? I'm telling you, can you just do this process over and over again, and then you get the hint, right? You kind of get the idea. So guys, let's go. Yeah, guys, when it comes down to the test, I'm going to be giving you every single formula that you're going to need, okay? So you don't have to worry about memorizing formulas. You just got to figure out which one am I going to use, right? Well, that's, again, guys, remember, hold on. Guys, remember, that's why I'm putting up the videos, and that's why we're doing these types of problems, because I'm trying to show you here how to do it, right? So, guys, remember, you'll have access to these videos. You're going to just have to go back and you're going to have to go back and watch what am I doing, how am I doing the problem so that you can figure out what's the process, right? Okay, so let's take a look at the next one here. It says the mean number of international migrants gained per minute in the United States in a recent year was about 2. All right, find the probability, that the number of international migrants gained in any given minute is exactly 5, at least 5, and more than 5. Okay. So guys, one thing I want y'all to do for me, please, let me see if I can find it, here we go, is if I look at my notes again, and I'm going to switch back to my document camera just so you can see it. Here we go. When we're looking at Poisson distributions saying the experiment consists counting the number of times X an event occurs in a given interval. The interval can be an interval of what? of time, area, or volume, right? Okay, so look, let's come back over here. We're talking about the number of immigrants gained per what? Per minute. There we go. So that's telling me, hey, you know what? This is going to be a Poisson distribution because we're looking at intervals of time. We're looking at minutes here, okay? All right. So guys, look at what part A says. So part A says we're going to find the probability of exactly how many? Exactly 5. Okay. So if I'm going to do this exactly 5, the first thing I need to know, number one, I need to know my mean. Do we know what our mean is? The mean was about 2. There we go. Okay. Guys, remember, on this problem here, I'm going to use my Poisson. And I'm going to find just one, PDF. So the first thing is I'm going to put my mu, and the second thing is I'm going to put my x. Okay? So in this case, since we're trying to figure it out for 5, wouldn't we go Poisson? What did we say our mu was in this case? 2. What's my x number? 5. Right? And then, guys, all I'm going to do is I'm going to grab my calculator right here. I'm going to turn it on. I'm going to clear it out. I'm going to go second vars. I'm going to scroll down. And I'm going to look for the Poisson PDF. There it is. And hit enter. And the first number I'll hit is a 2. And then a 5. And then we'll hit enter again. And 0.0361. What do you think? Is that right? 0.0361? Okay. 0.0361. Okay. Now, look at the next part here, guys. At least 5. What do you think at least 5 means? 5, 6, 7, 8. That means that our number is going to be greater than 5, right? So we're going to figure out what would it be for 5? What would it be for 6? What would it be for 7? What would it be for 8, right? Well, I don't know when we're going to stop. So couldn't we say, look, let's do, that's right, let's do 1 minus the Poisson CDF with our mu, with our average being 2. And if we want this to be bigger than or equal to 5, that means we want 5 or 6 or 7 or 8 or 9. So if I'm going to start at 5, which are the ones that I'm not including? 4 and so on and so forth, right? So then I'll just do this, right? And so, guys, again, I can grab my calculator again. We can go second vars. We can scroll down. What happened? Oh, I don't think I hit second. There we go. Second and vars. Okay, and that's the one we're going to use, and we're going to go with 2 and 4. Okay, there's my answer. And then we're going to go 1 minus that number. And so again, I'm coming up with 0.0527. At least 5. At least 5. Oh yeah. I'm sorry. I made a mistake here, guys. Sorry. I got a little wrapped up. Sorry. Let me see. Let's see. At least 5 means. Let's see. Yeah, at least 5 means. But doesn't more than 5 mean the same thing? What did I do? I'm trying to. Let me look at my notes real quick, guys. I wrote it out earlier. At least 5. Oh, at least 5. At least 5. But doesn't at least 5 mean 5 or more?
Yeah, because I put a note that bottom number that's going to be the bottom, 5, 6, 7, 8, or more than 5 is.
Yeah, but you know what I'm trying to figure out? Oh, you know what? Oh, at least 5. Okay, so does at least 5, doesn't at least 5? Yeah, no, we did that right. Because at least 5 means what? 5 or more, doesn't it? Yeah, so I'm sorry, we did that right. So remember, 5 or more would be 5 or 6 or 7, so on and so forth, right? So at least, but remember, Yeah, oh, so did I put 5? Oh, I should have put 4, right? Is that what you're saying? Oh, I did put 4? Okay, so that's what we should do. So, sorry, let me come back to my pen. CDF. So yeah, we said mean is 2, and we were stopping at 4, right? Okay. So let's see. And is that what we did on the calculator? Yeah, we did. Okay. So okay, no, I'm sorry, we did that right. So 0.0, what was it? I erased it. 0.0527. Okay. Now look what it says here. For part C. Part C says more than 5. What does more than 5 mean? Wouldn't that one be? But hold on. What does more than 5 mean? What's the first number more than 5? Whole number more than 5? 6. And then wouldn't that be? Okay, so guys, what's the only thing I'm going to do different? Okay, so I'm still going to do, but I did do CDF earlier, right? What number did we stop at here? 4. What number am I going to stop at when I do this one? 5, right? So I'm going to do the same thing again. 1 minus Poisson, CDF. We're going to go 2, we're going to go 5, and that should give us the answer for that one, right? So let's go like this, second bars. Poisson, CDF, and we said what, 2 and 5? Oops, sorry, I forgot the 2. 2 and 5. And then 1 minus? And so this one, are you coming up with point? Oh, you know what? Oh, did I do a normal one here? Ah, maybe that's where I messed up. No, but we did it earlier here, right? What number are you coming up with, guys? Are you getting the same number? Because I did CDF, that's why, right? So second bar, sorry about that, guys. Yeah, but I hit the normal, not the Poisson. You said, I mean, I hit a different button. I didn't hit Poisson. That's where I mixed up. 5. There we go. So 1 minus my answer. There we go. So 0.0166. Okay. All right. So guys, we got one last problem here. Let's do this one. And let's take a look-see, and it says fracking. 51% of U.S. adults oppose hydraulic fracturing or fracking as a means of increasing the production of natural gas and oil in the U.S. You randomly select 8 people. Find the probability that the number of adults who oppose fracking as a means of producing natural gas and oil is exactly 4, so on and so forth. Okay. So guys, again, if you come back and you take a look at your notes, we're trying to figure out, would I use geometric, would I use Poisson, or would I use binomial? If I come back over here and I look at my binomial formula, look what it says. Finding the probability of X successes in how many trials? In N trials, right? So when I read the problem that I have here, how many people are we selecting? Okay, so this is telling me that my number N is equal to 8. Do we know what the probability that people are going to oppose that? 0.51, right? Okay, so guys, for part A says exactly 4. So remember, if we're going to find exactly 4, this is a binomial, so I'm going to use my binomial PDF because I'm going to find exactly one value, right? We're going to use the number 8 for the first part. The 51, no, because remember, this is when the way you know when you're going to use binomial, they're telling you, you're going to ask so many people, what's the probability that out of those so many people, a certain number wants it? That's how it's telling me that I'm going to use binomial, okay? Guys, how many people do we want to pick exactly? 4, right? Okay. So again, I'm going to grab my calculator right here. Let me clear that out. So let's go second, bars. We're going to go to binomial PDF. There we go. And I'm going to enter in my numbers. So guys, remember, if your calculator is newer, it's going to ask you for the number of trials. You'll put 8. What's the probability? You're going to put 0.51. And then what's the number you're looking for, your x? You'll put 4. And when you do that, this is what's going to come out on your screen anyway. And I'm coming up with 0.2730. 0.2730. Okay, now let's do part B. Less than 5. Okay, so Myra, I think this might what you've been starting earlier. Less than 5 means what numbers? 0, 1, all the way to what number? To 4, because we're looking for less than 5, right? So guys, if I'm going to do this, couldn't I do binomial CDF? Because I'm accumulating everything from here. So we're going to go binomial CDF. I'm still going to look at 8. Still going to look at 0.51. And my last number, x, excuse me, would be 4. Okay. So let's get the calculator going. Second vars. Scroll, scroll, scroll. Excuse me. 8, comma, 0.51, comma, 4. Okay. Enter. Okay, so then now I'm coming up with 0.6147 or 46? 46. Okay, 6146. 6146. Okay. And guys, I'm going to do one more here. So there we go. Here we go. Okay. Now, this one says what? At least 3. So at least 3, doesn't that mean 3 or 4 or 5, all the way to how many people were they going to ask here? Excuse me. All the way to 8, right? Sorry about that, guys. Okay, so we could do binomial PDF a whole bunch of times and add them up. Or we could say, could we go binomial CDF and my n is still 8, my probability is still 51, but if I'm going to start from 3 forward, then I'm going to look at numbers like 0, 1, and what? So my last number will be the 2, right? And then guys, once we get that number, then we're going to do 1 minus that answer, right? So let's come back over here. Let's go binomial CDF. And I'm going to put, what do we say, 8, comma, 0.51, comma, 2, or we could have done second entry, I guess, right? Okay, we got that number, and then we're going to do 1 minus our answer, right? Oops. There we go. And I'm coming up with 0.8682. There we go. All right. So that was 4-1, or we finished 4-2 and we finished 4-3, guys.